Now in this example, it's about 4 girls soccer teams, and we want to find out, are they different in their scoring abilities? Now this is about this exercise is about girls soccer teams, and we're interested, are they similar in their amount of goals that they score? So you have the data up here, team 1, team 2, team 3, and team 4. I copied and pasted the data down here so that each individual, the number of goals that they scored, and then for each of the group 1, 2, 3, 4, we calculated the mean for each of these groups. Right here, each of the groups is the mean. We look at the individual difference between the individual and the mean for all of these people, all of these girls. We scored these differences, added them up, and that gave us the sum of squares within groups. Then we took the group mean for each of the teams, and we subtracted the grand mean from it. So the grand mean is the grand mean for everybody, right? If I click on here, the grand mean is the average across all the girls. So we get a difference for each group from the mean. We add those differences up, and that gives us the 25.75, gives us the sum of squares. And if we add that together, between plus within gives us the total of 38.95, and we can go check really quick if that's correct. Over here we have the individual scores minus the grand mean, which should give us the total sums of squares, which is 38.95. Then for degree of freedom for 1, we have degree of freedom 1 is for the between groups. So we have how many groups? We have 4 groups, 4 teams. 4 minus 1 is 3. Right below here we have the formula. Then for the within groups here we go n minus k. So that will be 20 players minus 4 teams. We have 16. And then for the total sum of squares, the degree of freedom is n minus 1. So it's 20 minus 1, which gives us 19. Then to get the mean squares between groups, we divide the sum of squares by the degrees of freedom, gives us 8.58. And then within groups, we get 13.2 divided by 16, gives us 0.825. And here you can see the ratio. You can see it's the between group mean square is almost 10 times as big as the within groups. Right? So already that tells you that there is a big difference between group variation and in the within group. So between these two, a big difference, and indeed the F ratio is 10, right? So about 10 times more variation between groups than within groups. And not surprisingly, the probability, the p-value of getting such a big F value is very low, if in reality there were no difference, right? So we conclude to reject our null hypothesis, right? Our p-value is way below 0.05, and we go with the alternative hypothesis. And here it's a good example. You could even see, even if we had adopted a very strict significance level of 0.01 or 0.001, we would still be saying that this F value is statistically significant. You can also see here that the F critical is 3.23, so we are way past that critical F value. So we know there's a difference somewhere. We can see there's one group has a 1.6 goals, the other group has an average of 3 goals, then here I have a group of average of 0.4 goals, and then 3.2 goals difference for the last team, right? So you can assume that the biggest team here, 3.2, is probably different than the lowest scoring team, right? Probably the fourth team here with team 2, right? 3.2 goals, 3 goals, probably not a significant difference. Then we could think about if 3 to 1.6 is significantly different from each other, or even if 1.6 to 0.4 is significantly different. So now we move into the post hoc tests to figure that out, and we'll do that at a later point in time.